Okay, so this video provides a review of the last step in the four-step process, assigning trips to a network. Okay, so we have a trip distribution table that gives trip interchanges from zone to zone. They're a simple four-zone network, which is shown here, and we want to take these trips and assign them to these individual links in this network. Okay, so step one is to find the minimum time path trees for each of the four zones. So the four zones are shown in yellow. The centroids of the four zones are shown in yellow. And we want to find the minimum time path tree from each of these centroids to all other nodes in the network. Okay, so first of all, I'm going to replace these yellowed node numbers with the zone numbers, so that we can keep track of where we're coming from. Okay, so we'll have zone 1, 2, 3, and 4. Okay. So the step-by-step process is as follows. If we start with zone 1, we want to find the minimum time path tree. We'll open zone 1, open this node, so that we'll travel to all other connected nodes. All nodes that are connected to node 1 will open this up like this. Okay. And the travel time, the accumulated travel time from zone 1 to this node is 5 minutes, and to here is 4 minutes, obviously. 5 minutes along this length, 4 minutes along this length. Now we've opened all the nodes that are connected to zone 1, so we're going to close that out. And now the next step is to then travel to the node that has the lowest accumulated travel time. In this case, it's node number 4. So we'll travel to node number 4 and open all of the nodes that are attached to it, or travel to all of the nodes that are attached to it. So we'll travel from 4 to 5 and from 4 to 3 here. Travel to those, and now the accumulated time from 1 to 5 through 4 is this 4. We've already got 4, and we're going to take another 3 minutes to travel from 4 to 5. So that's an accumulated time of 7. And from 1 to 3, it's 1 to 4 to 3. That's 4 minutes at 4, and then add another 2. So it took 6 minutes to get to node 3 here. So now we're done with node 4. We can close it out. Now we have 3 open nodes, and we're going to go to the one that has the lowest accumulated time, remember. So this is this one, because this has 5 minutes accumulated time, and we'll open this up now and travel to all of its connected nodes. There are only 2 of them. Okay, and the accumulated time to node this zonal centroid number 2 is 5 plus 2, or 7. To this node is 5 plus 3 is 8, and so on. Okay, so we'll close off this one, and now we have a situation where we can get to node number 5 via 2 different routes, and according to the algorithm, we'll close off, we'll take away the link that is not on the minimum time path. So obviously this is the one that is not on the minimum time path to node 5, because it takes 8 minutes to get there. We can go this way and only take 7 minutes, so we're going to close this off. This is eliminated from the time path tree. Okay, so now we have 3 nodes that are open, and node number 3 over here, this yellow one, is the lowest travel time, accumulated travel time. So we'll travel to all nodes that are connected to it. and it takes 6 minutes to go from 3 to 8, and we already accumulated 6, so that's 12 minutes from 1 to 8. And we'll close out number 3. And now we have 2 open nodes, no, actually 3 open nodes still, and there's a 7 and a 7, so either one, it doesn't matter which one we choose. I'll choose node 5, or no, yeah, no, I chose node 2 first, I guess. Okay, so we'll travel from 2 to 6, 4 minutes is 11. This should have been 7 over here. 5 plus 2 is 7, and then 11. Okay. And I'm going to now travel from node 6. Well, actually, node 5. Excuse me. From node 5, I'm going to open. That's the lowest travel time, so that's the one I'm going to use. And this is 11 minutes, and this is 13 minutes. And I'll close this off. So now this takes equal number of minutes, so we won't eliminate either path. They're both valid, they're viable. This one, however, takes 13 minutes to come from here. It only takes 12 minutes to come from here. So we're going to eliminate this link. It's not on the minimum time path tree. And then the last one, we have 12 minutes here and 11 minutes, so we're going to open this one up. And so 11 minutes plus 6 is 17 minutes to get to here. Close that out. And then there's one more from node 8. Travel from 8 to centroid of 4. That's 12 plus 3 is 15 minutes. Close out 8. Now you can see again, we've got a choice. We would not take this route from this node to this node because it takes 17 minutes. So we'll eliminate that one. So now when we're all done, we'll get rid of all of these links that are not on the minimum time path tree. And this is what we're left with. So this is the minimum time path tree for zone 1, all these blue arrows. And these are the travel times. Okay, so now the next step is to do it for the same thing for from zone 2. This is the minimum time path. I already did it. I didn't bother going through the process again. And zone 3, same thing. From zone 3, I'll go through that same process and find the minimum time path tree to all other nodes in the network. And node 4 as well. Okay, so now I want to assign trips. I'm going to assign trips from zone 1. So that's the minimum time path tree for zone 1. Here are the trips from 1 to 2 is 625. So always when you assign trips, always start at the destination node 2, or centroid 2, and then assign the trips to the links back toward the origin node. So 625, this is pretty straightforward. It's just 625 on these 2 links. So those are the trips on those links. Now from 1 to 3, I would start on 3 and assign the trips here and then here. The reason for that is if there's a choice at any given node, so for example if I got to 4 and I found I could go either way, then I would split the volumes, that's all. So now from zone to 1 to 4, again there's only one choice here, and I'll just assign the 800s all the way along. So that's the assigned trips from zone 1. I'm going to do number 2. So I have the minimum time path tree from node 2, and here are the trips, and once again I'm just going to go through these very quickly. 850 in this direction, 950 in this direction, and 2 to 4 is 750 in this direction. But again, even though there were no splitting, I always would start with the destination node for assign 750, and then if there's only one other choice coming into it, I just continue on with the 750. And similarly for zone 4. So these are the loaded minimum time path trees for each of the 4 zones. So now I have to combine them. So this is 1, this is 2, 3, and 4. You may or may not be able to see these numbers, but basically I just combine these. So for example, from 1 to 2, the link traveling from 1 to 2, what traffic is on that link in that direction? Well, I have 625 from 1 to 2 here, nothing from 1 to 2 here, it's going in the other direction, nothing here, nothing here. So the volume from 1 to 2 is 625. Now if I want to go in the other direction, there are no trips from 2 to 1 in this one. 2 to 1 here, there's 850, and no other trips from 2 to 1. So that's the only volume showing there. Now from 2 to the centroid of 2, I've got 625 and nothing here. Oh, but I have 450 on this one. So that's 450 plus 625. And then in the other direction, I have 850. And I'm trying to remember if there was anything here. Hold on. No, there was nothing here. Okay, so this is the only one. And again, from 1 to 4, I have 1550, and that's it in that direction. And then going from 4 to 1, there's 0, 0, oh, I have 350 and 1010 from 4 to 1. So that adds up to 1360. And so forth. So I basically just go through here and add all of the volumes, directional volumes on each link, and end up with a loaded network. And that's it.